The disease I'm presenting today is the smallpox. The family of the virus is poxvirate, and genus is Arthropoxvirus. Its species is variola virus. Here is an image of the virus. Its size is about 300 times 200 nanometer, which is much smaller than a red blood cell and about 50 times smaller than bacteria. The history of the smallpox remains mysterious. It is believed to have emerged in human populations about 10,000 BC. The earliest physical evidence of it is probably the pustular rash on the mummified body of Pharaoh Ramses V of Egypt. Perhaps the scars which appear on his body delicately preserved mummy dating back to 1157 BC may be the earliest signs of the smallpox exposure. It is speculated that throughout history, exposures to smallpox have been known in all parts of the world, along with the observance of gaining immunity to smallpox upon surviving in an exposure. The observance of such a phenomenon throughout history has led to healthy individuals to be exposed on purpose in attempts to gain immunity. The organism structure. The smallpox virus consists of genetic material containing a core. In this illustration, the external layer of blue surrounded is the outer membrane. The internal layer is the inner membrane. The virus is tidal, showing the rounded biconcave brick shape of the core, in whose depressions nestle the lateral bodies, which is in purple. The function of the lateral bodies is unknown. The blue layer surrounding the red part is a core wall. Inside the core wall contains a core, DNA genome, and viral enzymes. So next is the symptoms. The initial or prodromal symptoms are similar to other viral diseases such as influenza and the common cold, which is fever at least 38.5 degrees Celsius, muscle pain, malaise, headache, and prostration. At the digestive tract is commonly involved nausea, vomiting, and backache often occur. The prodrome, the pro-eruptive stage, usually lasts 2 to 4 days. By days 12 to 15, the first visible small reddish spots called erythema appear on mucous membrane of the mouth, tongue, palate, and throat. The temperature falls to near normal. These lesions rapidly enlarge and rupture, releasing large amounts of virus into saliva. So, life cycle. Here's a video of its life cycle. First, the virus attaches to a cell. Then the virus penetrates cell membrane and injects nucleic acid, which is DNA or RNA, into cell. The viral nucleic acid replicates using host cellular machinery. And finally, the new viral nucleic acids are packed into viral particles and released from the cell. The whole cell might be destroyed in the progress. So then we talk about the mortality rate. Historically, smallpox has an overall fatality rate of about 30%. However, the malignant and hemorrhagic forms are usually very fatal. The disease killed an estimated 40 million Europeans annually during the closing years of 18th century, including 5 reigning monarchs, and was responsible for a third of all blindness. Of all those infected, 20 to 60% and over 80% of infected children died from the disease. Smallpox was responsible for an estimated 300 to 500 million deaths during the 20th century. As recently as 1967, the WHO, who estimated that 15 million people contracted the disease and that 2 million died that year. After vaccination campaigns throughout the 19th and the 20th centuries, the WHO certified the eradication of smallpox in 1979. Smallpox is one of 2 infectious diseases to have been eradicated, the other being rabies, which was declared eradicated in 2000. Currently, the only remaining known variola virus isolates are frozen in closely guarded responsibilities at U.S. Centers for Disease Control and Prevention in the United States and the Vector Institute in Russia. Next is the transmission. Smallpox is very infectious. It's airborne, SARS form, but for it to be spread from person to person, a direct face-to-face contact has to occur. At a distance of greater than 10 feet, the aerosol begins to break down by the effects of both oxygen and UX rays from the sun. The virus can also be spread through the direct contact with infected body fluids or objects that have been contaminated with infected body fluids. People are the most contagious at the time of onset of the rash, and this lasts until the last smallpox scab falls off. Some cases have also shown to be contagious at the onset of fever, which occurs before the rash. Humans are the only natural host of the variola virus, and it never been known to be transmitted by insects or animals. Inoculation of healthy individuals by placing pus or powder scab material from an infected individual to a nose of intended was recorded by Chinese as early as 10th century. The procedure of inoculation of a healthy individual with smallpox was widely used in England by 1740. Around 1765, English physicians noticed that the milkmaids were immune to smallpox as a result of being exposed to the less served cowpox. As a result, in May of 1796, Edward Jenner, a brave scientist, inoculated an 8-year-old boy with cowpox virus and was exposed to smallpox. The boy becomes immune to smallpox, and Jenner was credited for creating the first smallpox vaccine. This became the starting point of the attempt to eradicate smallpox on a global scale, which was eventually confirmed and declared by WHO in 1980. The last confirmed case of smallpox in the United States occurred in 1949 and the last naturally occurring case in the world was recorded in Somalia in 1977. The vaccination. The smallpox vaccination is a live vaccinia virus closely related to the variola virus. Although the vaccine has a proven track record, supplies of the variant are very limited presently. In 1998, there were 19 million declared doses of the smallpox vaccine around the world. The potency of these doses is unknown, and various countries were attempting to determine whether new vaccines need to be generated. In 1999, countries started testing the potency of their vaccines. Currently, a division of the World Health Organization in Netherlands tests specimens every 5 years. Properly stored, smallpox vaccines has been shown to last 18 years without losing their potency. The vaccination usually provides individuals with immunity for about 10 years. If a person does experience symptoms, they're usually less severe. Even when the vaccine becomes less effective in people who are losing immunity, they are still less likely to transmit the virus. Those who are revaccinated after the first vaccination wears off usually hold their immunity longer than those receiving the vaccine for the first time. The neutralization antibodies can be detected during the first week of clinical illness, whereas humanizing inhibition and complement fixing antibodies are found in the second to third weeks. Neutralizing antibodies persist for many years or decades after infection, whereas levels of humanization inhibition and complement fixing antibodies generally disease within a year. Cell mediation immunity plays an important role in controlling diseases. Virus-specific cytotoxic T cells are detectable in lymphoid organs as early as 4 days after infection. These cytotoxic T cells are believed to limit viral spread by causing lysis of infected cells in the reticuloendothelial system and the skin. This is my works cited page.